Hey, I'm back with another quick Unity video about something that was confusing to me when I first ran into it, the Quaternion. This is something you'll start running into whenever you start doing rotation of objects, specifically like checking what the rotation of an object is in Unity, and it's very confusing because here's the thing, there are two different data types that can represent a rotation, and they're both used in Unity. First data type is the vector 3, which is what we see here in the transform panel under rotation. We have three values here from 0 to 360, and they are each an angle on the X, Y, and Z axis that we can rotate on. X-axis, Y-axis, Z-axis. They're called Euler angles after this guy Leonard Euler. He's the guy who came up with it and a whole lot of other stuff, and yet half of the world thinks his name is Euler. The other data type is the Quaternion, which is named after its inventor, Johann Quaternio. No, it's named after the number 4, I think. Now, a Quaternion uses 4 values to define a rotation. In Unity, they are float values between -1 and 1. I don't know if that's universal, but that's how Unity does it. So the reason this is confusing when you first run into it is because Unity uses both of these data types for the same thing, and it shows you different things in different places. To show you what I mean, I have a scene here with Suzanne the Blender Monkey. We can see in my transform panel, I have Euler angles for the rotation, and I have a script on it, which is going to simply print out the value of the transform.rotation. So what we see printed out in the console is the human readable string version of a Quaternion. We have 4 floating point values that are equal to this vector 3 of the Euler angles that we can see there. And as I update, say turning on the y-axis, you can see 2 of these values updating. I do it on the x-axis now, we see all 4 of them changing. Z, they're all going to change again. So this is confusing because these are not the same, these should be the same things, right? Most of the time you wouldn't even know this is happening because they give you the option in Unity to rotate your transform by an Euler angle, 3 values, or you can pass it a vector 3, and we're able to rotate it as we would expect to. We can see the Quaternion changing there if we're printing it out, but most of the time you wouldn't even know that. But what happens if I want to do something like I want my code to do something whenever my monkey looks down too far? Say the X angle is more than 15 degrees. Well, I could print out my Quaternion, set my X to 15 and see what this is here so I can check that. But then if I'm rotating something else, I still want it to trigger at 15 degrees if it's rotated a little bit to the side, but now this is all different. So you're kind of like, how do these two things relate to each other? How can I convert from one to the other? A good answer for how these two data types map to each other is math. A better answer is it doesn't matter. Because here's the big thing. Here's the elephant in the room. Why do we have these two data types, and why are we using both of them? Well, the thing is, Euler angles of the vector 3 are very easy for a human to understand, and a Quaternion is very easy for a computer to understand and work with. So anytime you have rotation data saved in any kind of software, it's very, very likely that it's only being saved as a Quaternion. And what's happening here in this transform panel is Unity is actually under the hood secretly taking that Quaternion, converting it to an Euler angle set, and showing you that, letting you change that, and then converting it back to a Quaternion so it can use that. But it doesn't tell you anywhere that it's doing that, so the first time you print out a rotation, you're like, what are these 4 things? Anyway, basically the answer is whenever we're working with rotation values, what we want to do is what Unity is secretly doing here, and they actually give you a way to do that pretty easily. So in my case, I wanted to trigger something anytime my x-axis angle is greater than 15 degrees. So I'm going to check transform.rotation, and rotation has a member called Euler angles. And that's what we want to be checking. Within Euler angles, that's a vector 3, so we can check the x, y, and z values of it. greater than 15. I do log getting dizzy, because you're looking down too far. That makes some people dizzy. Else log all is cool and good. And we'll see our check so far is good. All is cool and good. As we look down, look down, look down, look down. And now we're getting dizzy because our x is greater than 15. Still good as we turn around. So that's how you would check that. You can also go the other way and set your rotation to a set of Euler angles using the static method in the Quaternion class, Euler. And then you can pass it an x, y, and a z. So now I'm going to be, once I look too far down past 15 degrees, but less than 180 degrees. That's important. Then I'm going to set the rotation to 330 on the x-axis, which is negative 30 degrees. I'm going to be looking up in the air. I had to add this because I was confusing myself why it wasn't working, because obviously if I set it to 330, it's going to be greater than 15, and it's going to keep triggering. So I'm checking if it's not past 180 degrees, but it's greater than 15. Then we're going to snap him back up in the air. As I look down, oh. Once I passed 15, we're setting it to the Quaternion version of negative 30, 0, 0. So the big takeaway is there's really no reason to know or care how a Quaternion works or what it is even, except that it's what your computer wants to use, and you should know how to convert to and from the system that humans know how to use. Some ifs, buts, and caveats. There are situations where maybe you should know what a Quaternion is. If you're doing something like building a game engine, or doing something pretty computer science-y where you need to know how the computer is going to be working with this, it would probably be helpful to know. But for most of us who are using Unity, not building it, we don't know or care. Another thing to mention is that Quaternions do not suffer from something called gimbal lock, which is a situation where the Euler system essentially breaks if you're doing the X, Y, and Z rotations in the wrong order. You can end up in a situation where you're in one rotation and you want to get to another rotation, but there's no direct path to get there because two of your axes have lined up and the one that you want to rotate on doesn't exist anymore. I'm not going to talk about it really. There are lots of videos about what it is and how to get around it. Basically, you can get around it by thinking really carefully about how you're rotating on each axis so that you have the best chance of avoiding this happening. And lastly, I've been showing how all this works in Unity, but the Quaternion concept is not unique to Unity. It's a mathematical thing that is pretty much universal in computing. Godot engine calls it Quaternion. Unreal Engine calls it an F-Quat, and Amazon's god-awful documentation for their engine that no one cares about, they call it an AZ Quaternion. So I've been doing a lot of not really explaining anything because it turns out it's not actually something you really need to worry about. Most of the confusion, I think, comes from the disconnect between what you're seeing in the editor and what your code is seeing, and just realizing that there's one extra step to translate it into how we think we're thinking about it. So let me know in the comments if there's anything that's confusing or if you want to correct me because the public school system failed me. Also let me know if there's anything you want to see covered in a video like this in the future. With Unity, there are a lot of things that are confusing when you first see them, but if they're explained well, you can pick it up really quickly. Anyway, like, comment, subscribe, all that stuff. I'll see you next time. Bye.